All right, so let's talk about the first FRQ in the packet. I'm not going to do part A because I think you can do part A on your own. So I'll let you do that on your own, but I am going to pick up and do parts B and C. So part B asks, find all points in the curve whose x-coordinate is 1 and write an equation for the tangent line at each of those points. So if my x-coordinate is 1, and it's going to be on the curve, this is the equation of the curve, then when I plug 1 in for all the x's, I should be able to solve for all the y's that go with that x value. So I get a quadratic that I can solve by factoring, quadratic formula, whatever, but I'm pretty sure you get 3 and negative 2 as the answers. So that means my points are 1, 3, and 1, negative 2, and those are the points on the curve that have an x-coordinate of 1. I want to write the equation of the tangent line, so I need the slope for each of those. Well, then this is the slope. So I plug each of those points in for x and y. So my slope for 1, 3 would be 3 times 1 squared times 3, which is 9, minus 3 squared, which is 9, over 2 times 1 times 3, which is 6, minus 1 cubed, which is 1. So that's going to be 0. And then my slope for 1, negative 2 would be 3 times 1 squared times negative 2, so it'd be negative 6, minus negative 2 squared, which is 4, so minus 4, over 2 times 1 times negative 2, minus 1 cubed. So that's negative 10 over negative 5, which is positive 2. So the equation of my tangent line at 1, 3, I could write it with the full slope, but as the slope is 0, it's basically a horizontal line, so it's y equals 3. And then my tangent line at 1, negative 2, I'll just write in point slope form because that's a lot easier. And that's part B. Now part C asks, find the x-coordinate of each point on the curve where the tangent line is vertical. So there's two things that are being talked about here. On the curve and the line is vertical. So what I'm going to do is talk about the vertical part first. So a vertical line has an undefined slope. So that means my dy dx would be undefined. And the way this thing can be undefined is if the denominator of the fraction equals 0. Now, I want to solve this and get all the conditions that can make this equal to 0. So I'm going to factor out an x. So there are two conditions that could give me a tangent line being vertical. One where the x is 0, and the other where 2y minus x squared equals 0. So I'm going to take each of those conditions and I'm going to try to work them with the curve because it has to be both tangent line vertical and on the curve, and see what we get out of it. So I'm going to start with x equals 0. So I'm going to plug in just like I did on part B, 0 for all the x's. So I'm going to get 0y squared minus 0 times y equals 6. So that tells you that 0 equals 6, which never happens. So this condition isn't going to give me any place where the tangent line is vertical. So we look at the other one. So this is a relationship between x and y, right? So 2y equals x squared, which means y equals x squared over 2. Now, this condition would give us a vertical tangent line. It also needs to satisfy the curve. So I'm going to take this and treat it as a system of equations. I'm basically going to plug that x squared over 2 in for all the y's in the curve's equation. Now I'm just going to do some simplification here. Let's see, that'd be x to the 4th over 4 times x, so x to the 5th over 4. That would be x to the 5th over 2 equals 6. It's nice that those both come out to be x to 5th, so I can combine them. So basically I have 1/4 of those minus 1/2 of those, so it's negative 1/4 of those. And to finish solving for x, I'm going to multiply both sides by negative 4. And take the 5th root of both sides. Ooh, that was kind of a mess. Let me fix that. And all we were asked to find was the x-coordinate And although that number looks really weird and kind of frightening, it's actually the right answer.